Hi guys, Miss O'Connell here. So you should have watched the video that was posted above this link. Okay, it's a doc physics video. So in that video he explained kind of the conceptual basis behind centripetal force, centripetal meaning center seeking. Okay, he related it to Newton's first and second law. So really, Newton's first law is that objects in motion, they stay in motion at a constant rate unless an outside force acts upon it. So circular motion is really unnatural. Okay, it requires a constant force, and we know from our lab activity that that force points towards the center of the circle, right? It's center seeking. Okay, it's related to Newton's second law though. It's our centripetal force, F sub c, is equal to our mass times our acceleration. Okay, so in this example, we're going to use this formula, this concept that was talked about in the last video, and apply it to a few problems. So there will be separate videos talking about different examples. We'll start out with example 1. So in this example, we have a 0.1 kilogram object, which you see over to the left. It's moving in a circular path. We say that it's moving in uniform circular motion. The radius of that path is 0.5 meters. The maximum tension in the string is 10 newtons. Okay, so we know that in this system, that tension, T, is the force that causes circular motion. Okay, so just like in the stopper in our lab, that force causes circular motion. So that is equivalent to our centripetal force. It causes an acceleration and it causes that tangential velocity. Okay, so technically this acceleration is centripetal. It points towards the center, but it's based on the tangential velocity. So I know that's a little confusing. We'll talk a little bit more about that next week. But A is simply the relationship that you guys looked at in the video earlier in the week. So A is equal to v squared over r, and that v is equivalent to our tangential velocity. Okay, we know in this situation that our centripetal force is going to be tension. Okay, what we're looking for, what we need to find, is the velocity, the tangential velocity of the object as it moves around this circle. Okay, so in order to do that, we're just going to plug in what we know and solve for V. So we're told that the maximum tension is going to be 10 newtons. That's our centripetal force. That's equal to 0.1 kilograms, the mass of the object, times V squared, over r, the radius of our circle, which is 0.5 meters. Okay, so we need to get v squared by itself, so we need to do a little algebra here. I'm going to multiply both sides by 0.5 meters. You'll see it will cancel out on the right side of our equation. We're going to have on the left side of your equation, you're going to have 0.5 times 10, so we'll get 5 Newton meters is equal to 0.1 kilograms times v squared. We want v squared by itself, so we're going to divide both sides by 0.1 kilograms. Okay, technically a Newton is a kilogram meter over second squared. So it's going to nicely, through dimensional analysis, break down to just meters squared over second squared. Okay, but we're going to have to take the square root of 5 divided by 0.1. So we'll get 50 meters squared over second squared is equal to v squared. We want v by itself, so we take the square root of both sides. And our velocity, our tangential velocity, is going to be 7.07 meters per second. Okay, so knowing the maximum centripetal force, we can find the velocity. We can also go back here and find our acceleration. So if we wanted to find acceleration, let's try that in part B. Okay, so same example, we're just now looking to find strictly the acceleration. Okay, we want acceleration, we know force, mass, etc. So what we could do is we could just plug it into the centripetal force equals mass times acceleration, or we can use what we know about acceleration and its relationship to the tangential velocity we just solved for to find A. So either way, either formula is going to work. Let's just use the formula we just learned, to get a little bit more practice with it. So if the centripetal force is equal to the mass times the acceleration, we're looking for A. We know that max force is going to be 10 newtons. That's equal to 0.1 kilograms times A. We divide both sides by 0.1 kilograms to get our acceleration. And you should get 100 meters per second squared. Just for sake of emphasis, let's use the other equation and make sure that we get the same answer. So our acceleration is equal to v squared over r. We know that the tangential velocity is 0.7 meters per second. We have to square that quantity. That's divided by the radius, which we're told is 0.5 meters. So you want to square the velocity first. So we're going to have 7.07 squared. We'll get 49.98 divided by 0.5. You'll get 99.9, which is roughly, if we round to the nearest whole number, it's going to be 100 meters per second squared. Okay, so no matter which relationship you use, you should get the same exact values for your centripetal acceleration or the acceleration of an object in uniform circular motion.